start recording. Alright, so today is about loops, and I'm going to have us make a cute little game towards the end of class too, so I'm excited for that. So let's get right on into it. There should be plenty of time, I hope, to start your next assignment as I release it. So today, the bulk of the new knowledge is about loops and how to use them and do cool stuff with them. Because this is what a loop does, right? You have some code, it runs. You have some more code, it runs. You have some more code. This is just normal straight line code, block, block, block. A loop gives you the ability to revisit old code and rerun it a bunch of times. That's why it's looping around. That's why we call it a loop. All right? So the kind of loop that we've seen so far was our repeat blank times block. Look like this. It ate some other blocks. And so it said repeat, repeat, and then it's supposed to be an A, blank times, like you can put any number there, and the whole idea is you can put a bunch of blocks up in here, as many as you need, and those will get repeated n times. And I don't know, if you think of it like this is the head, these are the legs down here. This middle part where you put the code that you want repeated, we call that the body of the loop, all right? It's like the bulk of the work. So the body of the loop, that's what that's called. It gets repeated n times when you use this block, okay? Gets repeated. N times, or however many times you said. That's that. All right, so let's talk about loops in detail. It's exactly as it sounds, a loop. It's a special kind of block. There's multiple different kinds of loops. It's just a block that keeps getting run. There's multiple loop blocks, all right? You're able to, with that repeat n times block, you can specify exactly how many times you want that code to be repeated, or you can make it run forever. If you go to scratch.mit.edu, let me just show you all your options. It's down here in control. You got your repeat block, and you also have a forever block. It just never stops. That's possible. That's pretty sweet. So you got a forever block. Just continue until the end of time running this code inside of here. So forever. And that just runs within here exactly as long as it says. Keeps running forever. So that's kind of cool. That's useful because games are meant to not stop, maybe. What else? Yeah, so the body of that block, whatever your looping block is that you chose, it just gets run repeatedly over and over and over until potentially a stopping condition. Like, all right, that was 10 times exactly. Or you give some condition in a different kind of looping block that I'm about to show you. But we say that every time it runs that body, this middle part, once, every repetition, that if you say just once, though, that's called an iteration of the loop, all right? So we call that an iteration. It's just a fancy Latin root, just meaning to go. It went through the body once. All right. So it ran your code once. That's one iteration. It's repeating this body n times. It's iterating n times over your code, we say. All right, that's the terminology. There's another cool, probably the coolest loop block because it's the most general. You got the repeat until block. Let me zoom in. Because what does this take? It takes a pointy thing. It takes a condition. It takes something that will give back true or false. And so repeat until some variable has a new value, until the user gave me something that I wanted, until you have no more lives in your game. This is a very generic kind of block, and this can do all the others. It's pretty cool. So repeat until keeps repeating until a certain Boolean condition becomes true. So repeat until this happens. Repeat until the character is out of life. So that's the most generic and the most generic loop and the one we want to learn really well. So repeat until something pointy becomes true, right? So that's our condition of our repeat until block of our loop. And it's going to run its body as usual until that condition is true. So maybe it's going to start out false and be false a few iterations, right? Our new terms. And then eventually, one of these iterations is going to cause something involved in this condition to change and have that condition finally become true. Okay, that's going to be our goal. I'll show you plenty of examples with that. So repeat until that cond becomes true. Repeat until cond is true. All right. So, all right, for fun, here's our first example. Let's just make a scratch cat that bounces off the walls forever. That'll be fun. Let's try that. All right, so I won't use repeat until. I'll just use a forever block. That'll be nice. So let's say maybe when the green flag is clicked forever, we're going to have the scratch cat move off in a certain direction. So let's like give him a launch angle. And then forever, what do I want him to do? I want him to move 10 steps. And remember this block, if I click it, it moves 10 steps in his current direction. So that's cool. And if I run this, it's just going to forever run that. Boop. And then he's going to run into the wall and kind of like go into the corner there. That's no fun. Let's bring him back to the middle. 0, 0. There he is. If you want him to bounce off the walls, there's a block for that. Did you guys see it yet? It's here in motion. It's if on edge bounce. So see if you got the code exactly like mine. Compare against mine, please. So, all right, I'm going to click the green flag now, and forever it's going to run these two lines, these two blocks. Move 10 steps, and then see if you're at the edge. If so, bounce off in the nice way that you want to bounce off. So there he goes. And so this is running forever until you press the stop sign. There we go. And so that's an infinite animation. Very easy, a few blocks. Any questions about this? So this is a forever loop. It's got a body of 2 blocks. It's running those 2 blocks forever, just repeatedly. Move 10 steps, see if you're on the edge, and you want to bounce off of it. Just keep on doing that until the end of time. You get a cool looking animation. Any questions about that? And so it might not have been as cool if you started off the scratch cat in his default orientation, like 90, because then he'd just go left and right. He'd bounce left and right. Whee! But maybe that's what you wanted anyway. I don't know. But yeah, the initial direction, I guess, is kind of important for this one. But yeah, that's our first program. I'll save that so you have it later. Not too horrible, I hope. Any questions before I move on to it? Yeah. Oh yeah, so I think it has to do with the distance involved in this coordinate system. So let's make him 90 exactly. And so if I have him move exactly 10 steps, that I believe means increase your x coordinate by exactly 10. Yeah, I went from negative 91 to 81. So that's the distance it's talking about. It has to do with the coordinate system. Good question. All right. So, all right. Did I save this already? Yeah. Okay, so that's the first example. Let's do something a bit fancier, yet not as beautiful and animated. This is still important, though, all right? Because computers were invented to do math, so we better do some math. Let's write a program that sums the numbers from 1 to 10, all right? So I'll get the game plan in a second, but here's the idea. And oops, I was supposed to delete this. Delete this. Excuse me. There. Pretend it wasn't there. So, okay. We are going to, I'll make a cooler diagram in a second, but here is the idea. I want to make 2 variables eventually. Let's make a variable that holds the sum because I need to remember the sum from 1 to 10 eventually. So let's make a variable called sum or something. I'll do that in the code when I go to code. But okay, that's that. And then we're going to just like repeatedly add 1, then 2, then 3, then 4 into sum, and eventually it will hold the sum from 1 to 10. Get the idea? So if we want it to have the right answer in the end, we better start sum off holding 0, right? Don't have it like hold 42, because then you have 42 more than the right result at the end. So that's it should start off at 0. Then we would like to add 1 into sum, then 2, then 3, then 4, all the way to 10 into sum. And then once you've done that, you've got every number summed into the sum variable, and it's all worked out. All right. So you'll need maybe a second variable to keep track of like what you're about to add. Like we'll call it to add or something. So the first number I want to add into sum is the number 1. Place it in the sum variable. Now sum holds 1. Increment it by to add. Now change to add to 2. Add that now into sum. Now sum will be 3. See the game? So now add the 3 in. Now it's 6. And if I do this enough, I will have all the possible values. Now it's 4. Add that in. Now it's 10. And just do that until you get to 10, and you've added up all the numbers from 1 to 10. Does that make sense? All right, so that's the goal. And so we're going to need the second variable to like keep track of what we're adding, and then we'll just like show the sum at the end of all this. But here's an interesting idea. Look at all these bullets. Then add blank into sum, then add blank into sum. Those are repetitive bullets. That should scream loop in your mind, right? That's how you notice. Oh, this should probably be a loop. These bullets, these bullet points are repetitive. Repetitive. So, therefore, we should be using a loop, maybe. All right, so we'll look into that. So let's do that. Eventually, we'll use this kind of variable. We'll use a fancier loop. We'll use repeat until. But let's use repeat 10 because that's like we got 10 numbers to add in. All right, so let's code that up. And then I will draw again what's happening. Okay. What do I want here? So I want to make a new program. Sure. I'll erase everything. So when the green flag gets clicked now, I want to do some stuff. I want to start a sum variable. I better have a sum variable and a toAdd variable. So let's make both of those down in the variables section. So you get a default variable for free. Maybe I can right click and rename that one to sum, and then I'll make a new one called to_add. You can have spaces in your variable names in Scratch, but in most languages you can't, so that's why I'm using an underscore there. So sum should start at 0 at the beginning of the program. And then the first number that I want to add into sum is the number 1. So let's, at the start, also set toAdd to 1, because that's like the first number I want to put in. And then I loop, right? And then it's always take toAdd, add it into sum. Increment toAdd. Take that toAdd, add it into sum, increment toAdd. Does that make sense? That's the repetition there. So 10 times I want to do that. Repeat 10 times. I made a new variable called toAdd, and then this set block, you can change it to set a different variable than the default one. Right now it just has the first one's name, but you can change it to toAdd. Yep, just copy what I got, and that should do it. So I got 10 numbers that I need to add, so I'm going to do this repetitive thing 10 times, the process of adding in to sum the number currently in toAdd. So set sum to whatever it is right now, because maybe it's like 6, and toAdd is 4, bring that 4 in and make it 10. Set sum to the addition of itself and toAdd. All right, this will make sense when I draw an example, though. But that's the idea. So then maybe I just added the 1 into sum. Now sum holds 1. And I want to add 2 next time, and I want to repeat this code. So you can use this change block to quickly add 1 to a variable. So I want to increment toAdd, so change it by 1. So now toAdd is 2, and the next time we hit the body of this, it's going to set sum to its current value, which is 1 now, plus 2, because I just changed toAdd. We kind of see that happening? It's going, and it's changing, and it's changing. And by the end of this, I have added 1 through 10 into the sum variable. After all this is finished, and I can just have that be printed out to me. Like, hey, the sum is blank for 2 seconds. And so apparently the answer is 55, but that happened in the blink of an eye. So let's add a wait block to just watch this computation happening. Is that in control? Yeah. Let's have it wait a second in every loop body. How about that? Let's have it wait 1 second so we can watch these variables change up here in the top of the screen. So toAdds, add the 2 in, the 3, the 4, the 5 in. Now it's 15. Add the 6, 21, 7, 28. Add the 8, add the 9, add the 10, 55. Hey, there it is. And so also notice that toAdd at the very end is 11. Because like we're just repeating all this stuff. We're just not using 11 because we're not coming back that 11th time inside of the loop. Okay? Any questions about this? So this is kind of complicated. Any questions about this? Let's see here. So that's that way, and I want to save this. And then before I draw in detail what's happening, I kind of want to change this from repeat to repeat until. All right. So what's the idea here? Let's think of a condition that tells us when we want to stop adding stuff into the sum variable. Because to add is going to go from 1 to 2 to 3 to 4. And we want to add all those numbers into sum. But eventually, like it's 5, we add the 5. It's 6, we add the 6. It's 7, we add the 7. It's 10, we add the 10. But eventually, we want it to stop. So how about, okay, let's draw what's working, what this is doing right now. And I will eventually paste the new code because I want to do repeat until. Let's see. But here's our current code. I do want to change this in a second. But let me draw what's going on. Let me walk you through this. Remind me to still add repeat until. But we made these two variables, sum and to add. And we started sum at 0 and to add at 1. And then we repeated 10 times the process of setting sum to its current value plus to add. So, all right, sum equals itself plus to add. That's 0 plus 1. Store that into sum. So it's 1 now. That was this block. Change to add by 1. That increments it. Now it's 2. Wait a second. We can forget about drawing that. But that's one iteration. Then we come back. And now set sum again to itself plus to add. So set sum to be 1 plus 2. Now 3. Store the 3 in sum. You see how it's incrementing by 2 now? Now change to add by 1. Because that's the next number in the next round that I want to add in. Now it's 3. And then we wait. And then we come back because now it's the third time. Right? And then we add, we set sum to be itself plus to add. So it's 3 plus 3 is 6. So we just brought the 3 into here, storing the 6. All right? And that's the sum of all the numbers from 1 to 3. And then we want to add in the 4 next time. So we change to add by 1. You see how that's working? And then just repeat. Set sum to itself plus to add. 6 plus 4. Store 10. We just added the 4 into sum. Now increment to add with this change block. Make it 5. And then next time, eventually, we're going to get all the way to like adding in the 9. And it's like 45. And then we make to add 10. And then we come back one last time. Set sum to be itself plus to add. So 55. That's the final answer. Change to add by 1. 11. And then that was the 10th time we're done. And that's the final answer. So that's what's happening. Are there any questions about that? Now I'd like to change this from a repeat 10 to a repeat until, because that's the cooler kind of loop, and I want to get you practice with that. So what's a condition? We need to look at this and be like, what would the condition be that should stop our loop? I want to repeat this process. We can keep the same code, but I want to keep repeating until what happens? I don't know what the sum is supposed to be. That's why I wrote the program. So I can't be like, repeat until the sum is 55, because that would be kind of sidestepping the issue. But I do know how many numbers I want to add, right? I want to add up to 10. And eventually, to add is going to get bigger than that if I let this change block keep running. Eventually, it's going to hit a number that I don't want to add into sum, like 11. So that is a good stopping condition. I want to repeat this process, repeat this body, until to add is bigger than 10. Because I don't want to put 10, I don't want to put 11 into sum. I want to stop at 10. So this is a good stopping condition for a repeat until loop. All right, so stop. Let me spell stop correctly. Stop when to add is greater than 10. And that's the secret. All right? When to add is greater than 10. And we can change this now to repeat until. I did save this, right? I think so. Okay. So that's this one. Let's change this to repeat until now. Here, how about I just put this code to the side? Duplicate. This is the old code. Here's the new code. I'm going to swap out this repeat for a repeat until. There. Keep that body code. Get rid of this. Everything's the same. It's just we add our stopping condition explicitly. Repeat this process until 2add is too big and I don't want to add its current value in anymore. Like it's going to start at 1, it's going to go to 2, 3, 4, 5. I want to add 10 in, but the second it gets to 11, and it will get to 11, remember, I want to stop then. Don't add 11 into sum. Okay? So repeat until 2add is greater than 10. So I go to variables, there's 2add, and then there's 10. And this is another kind of loop. It repeats until this condition is true. And so watch it work. It's adding 3, the 4, the 5 in, the 6 in, because 2add is still smaller than 10. 7, 8, 9, and still, there it goes. And then now it's 11. Is 11 greater than 10? Yes. Then it finally stops. It keeps running the body because that was false before. 2add, if 2add was 1, is 1 greater than 10? No. Is 2 greater than 10? No. Is 10 greater than 10? No, not strictly. But once it's 11, that's going to stop our loop. Okay, so that's the cool way of doing this. Are there any questions about that condition there? Yeah.
How did you get the sum block with the I only have the 2add.
This block, this green one? Oh, this one? Oh, okay, yeah. When you make variables, you can check them to have them always be displayed. If you just want to see them in the code, in the final window there. Yeah. So that's our cool way of doing it. Any other questions about that? So we found a condition. We found a good condition, and that stops us. All right, so I'll give you this code. Oh, yeah, question first. Say that again? Oh, sure. Yeah. So watch it add the 2 in, the 3 in, the 4 in, the 5 in, the 6 in, the 7 in. And it's always changing to add by 1. Now it's 10. It's still greater than 10 is false. And then now it's 11. It's done. It skips the loop body. The loop is finished at that point. Oh, yeah. Because it's instantaneous, you got to add a wait block. I added this wait block here so that we can watch the value for a second. Oh, you do? Yeah. Oh, so you have an infinite loop right now? Accidentally? Oh, sure. Let me come take a look. It's worth getting this right. Looks like we got to start. You got to set sum to 0, not minor. It's not using the right start. Oh, yeah. Yeah, you're getting it. So I just want to bring that code. It's a little weird. Definitely watch the older videos. But yeah, I'll totally help you. Yeah.
I'm kind of having a little trouble too, sir. See how I copied your code like I did, but it's not working. See, I did the block. It went open.
Oh, too bad. You want to set sum to. It's not exactly the same. Look at yours and look at mine. Set sum to sum plus 2add. Then change 2add by 1, and then you have an extra variable called add.
2add right here.
Yeah, but you already have that, so you want to like delete one of those. Yeah, that's
There we go. I think that's gonna work.
That's the better way.
It's not functioning. So if I click the green flag, it doesn't work.
I think it happens immediately because you don't have the wait block still.
What block?
The wait block. There's a third thing that I added that you didn't have. All right. So this is good. I'll come around and help more people, but I want to give you a question first. All right. So here's this code. Here's your question. Get my way working, and then take a couple minutes to work on this. So instead of adding from 1 to 10, please change my code to sum from the numbers 1 to 25, but only the odd numbers. Please sum up 1 plus 3 plus 5 plus 7 plus 9 all the way to 25. Figure out that answer and say that. All right? You see what you might change? So give that a try, and then I'll come around and help people. Give you a few minutes for that. Try and change it to add from 1 to 25.
125.
Just like it says. And then in another 2 minutes or so, I'll show you my answer. Shouldn't be too much you need to change.
Yes, I got to 21. I think I found the answer 21. Got 7.
See if you can find what needs to change there. Let's see what the real answer should be. I don't remember. Now I know the answer, so I can check it if it's wrong. All right. So, what do we need to change? Right now, 2 add is going from 1 to 10. How do I make it go up to 25? How do we change that?
I think I have an idea.
What?
If you change the greater, put the number from 10, change it to like a smaller number, and maybe it'll add up.
Definitely not smaller, but that's the right idea. Like, I wanted 2 add to stop at 10, so I said keep going until it's greater. I think I could change this to until it's greater than 25, because after that I don't want to add anymore. Does that make sense? Is that what we got? So that's how you can stop it at 25, but then I want to have it go by 2s. So like, instead of going to 2 next, and that's the next number I add, I want it to be 3 next, then 5, then 7, then 9. How do I have it work like that? And then eventually 25, and then the second it's 27, I don't want to continue, right? That's going to be stopping it, right? That's why we had that. How do you make it increment by 2? How do we do it? Well, which block is having an increment by 1 right now in the code? That's what has to change, though. Where was that? Yeah, it's this change block. This is what's adding 1 to it right now. So if I want to make it 3 next instead of 2 next, I better add 2. That's all. Because that'll make it 3, then 5, then 7. I don't want it to be 1, 2, 3, 4. It must be too late in the day for programming. I respect that. All right, so yeah, that's all. 25, 2. I'll get rid of this wait block because it takes too long, but it's going. 7, 9, 11, and eventually it's going to be done. Let's watch it work. Why not? Adds the 3 and the 5 and the 7 in, the 9 in, 11, 13, 15, 17, because 17 is still not greater than 25, 21, 23, 25, 27, and there it is, the answer. Apparently it's 169. That's all those numbers. All right. So yeah, that's how you do it. Any questions about that? Does it make more sense? That's how you'd sum all those numbers. Alright, so that was loops. That's how you repeat stuff. Let's go back to conditions, because those are other pointy blocks. I have a fun Halloween-themed idea for us that involves getting more exposure to Boolean expressions. So I'm going to make a program that's like scary, and we're going to ask the user if they believe in ghosts. All right, this is my idea. We'll ask the user if they believe in ghosts. If they do, we will set a special variable. We'll call it like should show ghosts or something, and the ghosts will be watching this variable. And so if we believe in them, they will show themselves. And then if we say what we don't believe in ghosts, they will not show themselves because they're watching that variable still. So like should show ghosts started at 0 because we don't know yet. Hide the ghosts. But the second that variable becomes 1, the ghosts wake up and they show themselves. All right? So they'll be summoned depending on that value of that variable, and they'll just watch it forever in like a loop, in a forever loop. So here's this idea. Let's see. So I saved this, I believe. Let me make a new program. So, all right, we need to set the scene, of course. So backdrop, we need like scary woods. Yes. Here's the Scratch Cat. We can call him Scratch Cat. And then I would like to add a sprite, add a couple ghost sprites. Is there a ghost? There's a ghost. Or does it not work? Ghost, please, add yourself. Did I lose the internet or something? Huh. I should be having a new sprite on my screen. Alright, I'll try it a third time. Does the ball work? I can't add sprites right now. Let me refresh the page, sorry. Something's going wrong here. Okay, yeah, there's something wrong with my internet, maybe. I'm glad you got it. Yeah, I think there's something wrong with my internet. Oh, man. Well, exactly. So, let's give it a little bit. Maybe I can... Or is all of the internet down for me right now? Like, can I go to the class website? Yeah, my computer's just unhappy. So, let's see if the web browser was the problem. Sorry about this. There's always technical difficulties in a computer science class. Okay, yeah, it was probably Firefox's fault. Will you load this time? Oh, okay, cool. Nice. And then I will remember to stop attendance just in case this isn't happy later. Alright, scratch.mit.edu. My poor browser. Alright, start creating. So I'm going to add in a couple ghost variables as well as this woods backdrop. It's surprising that it loaded the woods, but not the ghost. Maybe that was right then that it stopped working. Okay, cool, it's working now. What are some other scary things? I think there's a skeleton. And then I think there's a bat, too. I think I used the bat last time. So let's have the bat be our third scary object, our third ghost. So here they are, spooky. And here's the Scratch Cat. So we got 4 sprites in our program. And let's see, the Scratch Cat is going to be like in control. We're going to have him ask when the green flag gets clicked, do you believe in ghosts? Where's that? Is that in sensing? Yeah, it's been a while. Ask, do you believe in ghosts? And wait. And so we'll get that answer. And depending on that answer, we're going to set this special variable, right? We're going to call it should show ghosts. So let's have that work. So variables, let's rename this default one to like should show ghosts, or whatever you want to call it. And that is going to be set based off of this answer. So like the user might say yes, and if they do, if they say yes, we want to set the should show ghost to 1, otherwise we want to keep it at 0, yeah. I put for all sprites, because they're all going to be watching. Yeah, good question. I just renamed the default one, actually, and that's already for all the sprites. But yeah, if you make a new one, it should be for everybody. So they're all going to be looking at this. So do you believe in ghosts and wait? At the start of the program, we should make sure to initialize should show ghosts to 0 because we're not sure yet. And the ghosts want to hide themselves when it's 0. That's going to be our game plan. So at the beginning, let's make sure that it's 0, and then we'll ask, do you believe in ghosts? And then we'll get that answer from the user, and we'll set should show ghosts accordingly. Right? So control. We'll have an if-else block. Yes. So if the user typed yes, then we should set should show ghosts to 1. That's going to be the special number that they'll watch for. If it's 0, they'll hide themselves. If it's 1, they'll show themselves. That'll be the game. All right. So if the answer was equal to, there's an equals to block. If the answer was equal to yes, then we want to set should show ghosts to 1. Otherwise, we'll keep it at like 0. Technically, it already is 0, so you don't really need this else part, but whatever. That's fine. So here's the program so far. Do you believe in ghosts? Initially, should show ghosts is set to 0. If I say no or something, it's going to stay 0, because like the answer wasn't yes, it'll hit the else. But if I do say yes, enter, the should show ghost variable gets set to 1. See that? So that is how this will work. We're going to have the ghosts watching this variable in their own programs, right? So this was all the Scratch Cats program. Let's go to the ghosts program now. It's blank. He's got nothing so far. Let's have him do something. So when the green flag gets clicked, Mr. Ghost, I would like you to constantly be watching this variable. All right? Constantly be watching this variable. Forever watch this variable. All right? And depending on its value, do something. If it's 0, hide yourself. If it's 1, show yourself. Does that make sense? So we're going to compare this variable. If should show ghosts is 1, then show ourselves, otherwise hide ourselves. If it's a 1, we should show ourselves, otherwise we'll hide ourselves. And I think that's in looks, I assume. There we go. So if it's a 1, show ourselves, otherwise hide ourselves. And so forever, we're going to keep on running this if statement every nanosecond or something. And so the second this variable changes from like a 0 to a 1, now it's just going to keep showing itself. Does that make sense? So here's the Scratch Cats program again. It's setting this variable, and then ghost, the ghost is going to be watching this variable, right? So at the beginning, look at how it's set to 0. It's following that. It's hiding itself. Like, is should show ghost 0? Or sorry, is should show ghost set to 1? No, false. So it runs the else, hides itself. But if I say yes, that sets should show ghost to 1, and it shows itself. Ooh, any questions about that? So just watching that variable. That's pretty cool. And so essentially, I want to give the same program to all the ghosts. They have to do the same thing. They show themselves if the value is 1, otherwise hide themselves. And so an easy way to give this code to another sprite is you just drag it onto their picture, and it starts jiggling. I dragged it onto the skeleton. I dragged it onto the bat. And that will copy it to them. So now they all have this program that they'll be running separately because they are their own entities when the program starts. So now, green flag, look at how they all hide because they're all watching this variable. Should show ghost equal 1? No, false. So hide. And so if I say no, enter, they stay hidden because should show ghost is still set to 0. They're watching this variable. They think maybe it's going to change later if we change the code, but you can see how these blocks are highlighted because the program is still running for them. It's a forever loop, so you can click the stop button to undo all that. But that's the idea. So if we say yes, we do believe, then that will set the variable to 1, and all these ghosts will come alive because should show ghosts equal to 1, it finally was 1, and so they'll run this show block. Yay, there they are. Any questions about that? So this is a multiple program. Each sprite is doing a different thing. How fun. Let's see here.
Can you go back to the Scratch Cats program?
Yeah. There you go. Let's see. How do I want to do that? could be fun. Oh, hey, Derek, what's up? Oh, sure.
Your door of your office was
Uh-huh.
was I put tape on it. So the doorknob still doesn't work.
Much.
A little bit more secure.
I can have office hours there today, then. Thank you very much. Okay. All right, there they are, all beautiful. All right, so a little bit. So I've copied that code. They all need to share it. Can't really. There's a way, but it'll take a while to get to the answer to that. But that's a good point. Any questions about the code so far? I do have a slide explaining it a little bit more. Maybe we can wait for that one. All right, so here's how it kind of works, right? I'm entering in my answer, and that's changing the answer variable. I'm checking that for yes. Was it yes or no? All right, and then I use the value of that answer, yes or no, to set the should show ghost variable, because that's going to be a 0 or a 1. So if it was yes, set it to 1. Otherwise, set it to 0. Okay, that's the goal. And then each ghost is tracking that variable's value. It's like if forever, keep checking. Has it changed? Has it changed? Has it changed? If it's 1, show myself. Otherwise, it was not 1. We run the else, hide ourselves. All right. So hides or shows depending on the value of that variable. Any questions about that? That's the beauty of it all. Let's see here. That might be fun to make them flicker. I can't quite remember what I did last time to make that happen, but that's a good example. If there are no questions for this code, are we good? Yeah. All right, let me save this before my internet stops working again. Let's see. I would like the ghosts to flicker. How should I do that? How about I set their ghosts are ghosts, right? They're supposed to be kind of see-through. There's an effect for that. Change the color effect. No, that does this. It's like changes the color of the ghost, which is really cool. You should look into these blocks and play around. But let's go back to the start. I don't know what the start even was. Clear graphic effects. There. You can change the ghost effect by a certain value. And how about every time how about we not change the ghost effect, but we set the ghost effect? It's like 0 is like a percentage. 0% invisible, 100% invisible. Let's set the ghost effect every time we run this loop, because it's going to happen a lot, to some random value. How about that? And there's a random number operator here. Pick a random percentage between like 25 and 100. Or sorry, how about 0? I think 0 is no ghost, and like 75 is 75% see-through. I think that's what that means. So let's try that. And I say yes. Cool. He's flickering now. And so what's happening is like a million times a second, it's setting this transparency setting on the ghost sprite to some random number between 0 and 75% ghostiness. That's pretty fun. So hopefully none of us are going to have any issues with that, because that's I don't want to cause any seizures today, that's for sure. But that is a ghost effect. Why not? There they go. And it's a different random for each of them. Why not? That's kind of fun. All right, so please play around with this. It's a fun little idea. Scratch is nice because you can make animations and change the colors of things and stuff like that. But let me give you my program. Let me zoom out. Here's this. And I want you to just play around for a little while. I bake time into the class for this because it's worth it. This is how you learn. So here are the ghosts program. They're running the same thing 3 times each. And then here's the scratch cats program. And please take a while, help each other, find something cool, and share. But here's my code. Recreate this example if you haven't already, and add something to it. Like have the ghosts all say boo when they wake up, or something like that. have them like float around. You know how to change the position, right? You can have them do that bounce around the screen thing like I was doing at the beginning. So do something cool. I'll give you a few minutes to just play around.
Okay. That way I could just see it a little closer.
Yeah, it's the perfect spot.
Let's do it. Let's get started.
Yeah, take like a few minutes to play around with this. We got plenty of time. I'll give you 5 minutes, let's say.
Okay.
And that pick random number between something and something. It's a great little block. That's useful.
It gives me an idea. Well, let's ask him another question, then we'll ask another question. Hold on. Gotta fix this. Are you scared of it?
There are any questions, of course.
Are you scared of ghosts?
One might pick random 25 or 25, the other might pick a random number 35.
Okay. Like I'm having to ask another question.
Okay.
Like, are you ever afraid of ghosts? How about you, Mr. Nicholas?
Yeah,
Are
definitely.
you scared of them or not?
I used to be. Definitely.
No.
I like the way you go. Like maybe you'll ask, are you scared of him now? And then it'll hide them.
Yeah, this is so much fun. It's like, oh my god.
This will be the Scratch Cats program when the green flag gets clicked. And this will be the program for all of the ghosts when their green flag gets clicked. So they're running separate programs at the same time is kind of how that works. It's a little weird. It's actually a very complicated computer science concept, running separate programs at once, but it's just so natural in Scratch. You guys are running things like the CSCI still running, so the transfers before you publish. All right, another minute or so, and then we'll move on. I'll show you how to make a game.
No. Cool, that was awesome. Do you see a ghost? Do you see a ghost? Okay.
Alright, that's my timer. I hope that was fun. There will be plenty more time to play around with that after I finish the lecture and give you your next assignment. So keep it up if you'd like. But I have one last example. So if you want to save what you got, you can go file save or something, or just make a new tab or whatever, if you want to still follow along. But the last topic for today is I want to show you how to make like a little platformer game. And so that's like Super Mario Brothers or something like that.
Love that.
And the idea of a platformer game is like you can move side to side and you can jump on those little platform things. That's why they call it that. So let's make something similar to Super Mario, just a little bit simpler because this is new to us. But let's make a little program where we got a character. We'll have our Scratch Cat be our main character, of course.
Okay.
And we'll have him be able to move horizontally with some arrow key presses. We'll have him be able to jump, and then we'll let him like interact with something, okay, on the screen. So let's talk about all those things. So let's get the Scratch Cat jumping first. I think that'll be helpful. That'll be nice. So let me make a new program, clear it all out, and when the green flag is clicked, I would like nothing to happen, actually. So I actually want to do stuff when keys get pressed this time. So like, let's have space be the jump key. And so we'll have like the Scratch Cat down here. And we want to have him jump when the space key gets pressed. So what does it mean to jump? You have to program this, right? So jumping is an increase in your y coordinates value, right? That's all jumping is. You're going to increase the y coordinate value by a huge amount. So like bring him from down here, make him go up there. All right? So that's what happens when the space key gets pressed. That's what should happen. That's what it means to jump. So I assume this is in motion, right? Change y by something. 10? I'm going to press the space key now. That's not enough for a jump. How about 150?
Okay, that's right.
Space key. That's pretty good. That's a decent jump. So, I don't know. How about 175? That might be the right amount. And then there should be gravity too, right? So you jump and he changes his y by 175. He should also fall down back to where he started. Yeah. So what should we do about that? So jumping is quickly increasing y, like he built up his jump. He increased that y quickly. He warped there. And then let's bring him down slowly until he touches the ground. And we'll use like a repeat loop. Repeat like 10 times loop. Bring him down gradually, because that will show a few frames. So let's make it like 180, because I can like do this. Watch. So change y by 180. That jumps him up here. And then, how about 18 times? Repeat the following. Change y by -10. See where I'm going with that? Change y by not 10, but -10. If I do that 18 times, he will have moved down 180 in the y direction. So he's going to go back down to where he started. But the fact that this is in a loop means it takes a little bit longer to do that, and we see some animation because of it. All right? But he's still going down 180 because I put him up 180. Whee! There he goes. So that's a decent jump. Press space, and eventually he gets down. Any questions about that? That's like a start of something. All right. So what next? We have to let him move horizontally as well. So like, let's go back to events. This is all just when keys get pressed. So like when the left arrow gets pressed, have him move left. What does it mean to move left? Well, that's your x coordinate, right? Have that change. So that's motion. Change x by -10, because we're going in the negative x direction. So if I press the left arrow, he kind of like does a moonwalk backwards. And then we want to do the same thing for the right arrow. When the right arrow gets pressed, change that. Change x by 10, because we want to go right. That's the positive x direction. So now I can move left, move right. You can hold it in too. Whee! And we can jump. And you can actually kind of move him as he jumps and falls, because that's how games work anyway. Isn't that nice? And if you want to control how fast he falls, you can add like wait 1/10 of a second every time you're inside of this, or like change it by even less, like make this 36 and change y by -5, as long as it adds up right. Then he falls a little bit slower. I don't know. Whatever you want. Let's go back to how it was, though. But are there any questions about that? So left arrow, change x. Right arrow, change y. Space, warp up 180 in the y direction, and then go back down to where you came, just slowly, in an animated style. Just run these blocks 18 times, which kind of looks animated, because it takes some time to run those. All right, let's give him a name, Scratch Cat. So let's make a game out of this. Let's,
Which cat? What's it called again? What are you calling him again?
his name is Scratch Cat.
Scratch Cat.
So let's make this game. Let's have him be underwater, so be at underwater level. Let's have him be able to jump up and collect fish, because cats like fish, right?
Okay.
So let's add a fish into our scene. Let's add a backdrop of like the ocean, underwater. Watch it. Underwater 1, sure. Cool. And then we'll add a fish sprite. There's a bunch of options, but here's got like Nemo or something. And all right, I would like to make a game out of this. So Scratch Cat moves left and right, and he like jumps up and he catches the fish when he touches them. Something like that. It's like a coin in a game. Oh, is there something wrong with the screen? Oh shoot. I'm glad I caught it in time. Let's this usually solves that. If not, I'll have it reconnect. That's so weird. You know what I bet is that every hour on the hour, because it just turned to be 5 o'clock right now. Probably every hour it like disconnects.
I got the fish.
Alright. So jump up, collect those fish, Mr. Scratch Cat. And let's have something cool happen whenever he touches the fish. Alright? Let's have him like gain points. So let's add a variable that keeps track of. Oh man. Alright. Getting too excited. Let's see. This room, maybe the room is haunted. How about that? I was trying so hard. There we go. So let's have when he jumps up, whenever he touches a fish, like he gains a point. All right. So let's have a points variable. Let's add that. I'll change the default variable to be called like score or something. Score. And let's see here. I kind of do need to start a game now. Like maybe when the green flag gets clicked, we should like zero out the score. How about that? We can do that. So a lot of different events happening right now. And we can show that with the checkbox. So every time the Scratch Cat touches the fish, he should like get a point. All right. So let's make that be the fish's job. All right. So when the green flag gets clicked and the game begins, the fish, actually the fish can be in charge of the score too. How about that? How about the fish sets the score to 0? And then forever, whenever the Scratch Cat is touching the fish, because this is the fish's program right now, we'll change the score by 1. How about that? So we have to have the fish repeatedly keep checking, is the Scratch Cat touching me? Is the Scratch Cat touching me? So that'll be a forever loop. And then we need an if inside of that. Forever keep checking if the Scratch Cat is touching me. If so, change the score. Right? So there is a condition for that. It's in sensing, I think. And so it's always from the perspective of the thing. There's a touching block. It's always from the perspective of the sprite whose program this is. So this is the fish's program. So it's like if the fish is touching the Scratch Cat. This will be true if that's true, right? So right now it's false because they're not next to each other. But if they're next to each other, then it becomes true. And that will cause this to like get a point. Okay, so if that's true, then change score by 1. So that's the idea. That's the fish's game. So watch the Scratch Cat. I'm going to jump, and that will change the score by apparently 4 each time. That's a little weird. So the idea is there's 4 frames of this animation where the Scratch Cat is touching the fish. And so it's like incrementing by 4 each time, which is not what we want. So there's an easy way to fix that and also make the game cool anyway. So here's the last part. Let's have the fish disappear the second he gets touched. And we'll have him teleport to a different x coordinate. So he's like going to move left and right. A different x coordinate. Keep the same y coordinate. So stay up as high as you are, but just like maybe warp over here, warp over here. Something like that. That's the goal, right? So that will also keep it from having more than one score point each time. So if the scratch cat is touching me, give him a point, and then warp myself somewhere. Like, that's in motion, I assume. So change x by some amount. Like either in the positive direction, negative direction, or how about just set x? What's the lowest we want it to be? Maybe negative 150 to positive 150? That looks good. So some random number on operators between negative 150 and positive 150. So if the scratch cat touches me, this is the fish's program, I want to increment that score and then set my x to be a random place, a random location. All right? That's the idea. So I believe that'll do it. So now if I run the program, the scratch cat is able to move and jump, of course, and then the fish is always, this program's still running for the fish, it zeroed out the score, and now if the scratch cat's ever touching it, boop, it warps and gives me a point. Whee, warps over and gives me a point. There he goes. And so that is a decent game. Question?
Mine's just going off the screen a lot.
Okay, you'll have to look into a few things there. So if the score keeps going up, that means the scratch cat's touching him for too long. And that was the problem we just had. If you change the X, though, if you have him warp for a second, then it should be all right. There is a possibility, though, of still having this problem because the fish might warp to the same spot, and that'll also increment the score by too much. So a way to do that is to hide the fish. The fish cannot be touched if he's hidden. So if we hide the fish, set the X to a random spot, maybe wait a second to like plop up somewhere else in control, and then show yourself, then we're kind of guaranteed, more or less, the scratch cat will have fallen by a second then, and it won't be touching the fish. That will fix the incrementing by too much, because the reason it did that is because the fish was checking like every nanosecond, is the scratch cat touching me? Is the scratch cat touching me? And he was for more than a few. Does that make sense? So this hiding and waiting while you're hidden, that will, I think, be a little bit better. And so that will force it to only increment by one. There he goes, and then he like plops up who knows where. And yeah, so after 1 second is the right way to do it. Any questions about this code? So the scratch cat's got an easy job. He's just like, when any of these happen, do my stuff. And the fish is like the bulk of the work. Forever keep checking, is the scratch cat touching me? If so, man, I need to hide myself, move over, show myself, increment the score, all that stuff. But in that order. So that's a cute little game that I will save and give to you. Any questions about any of that? So do study this, because this is more or less the topic of your next programming assignment. So let me give you that.
Yes, I will.
Alright, so over here we go. Programming assignment 2. This will be due the 31st. So, you know the drill. A new programming assignment every week, more or less. So this will be next week. Here is your job for programming assignment 2. Here's the program that I want from you. Just implement your own little platforming game. Following features are what I require. So you gotta have a little character sprite. Pick whatever one you like. Maybe somebody other than the scratch cat can be the main character this time. Have him be able to move left and right with the arrow keys and jump with the space key. So those are hard requirements. Then I want something cool to happen when you touch or jump into some other sprite, like we did with the fish today. All right. Another requirement is you better have at least 2 loop blocks in your program. Jumping was one, and then we did a forever loop as well for the touching stuff, but you can add your own. At least 2, though. And you can, of course, use my demo as a starting point, but you will get a 0 if you just copy what I did. All right? So please make your something cool be unique. Make it be exciting. Maybe you can bring it back to the ghosts example from before or something like that. But yeah, just make your own version of this and show me that you can extrapolate from the things that you've been learning. Okay? So make it creative. I am requiring video submissions now. So make sure you've got that ready. Ask me right now after class if you're having any trouble getting this current assignment's video recorded. But yeah, from now on, I'm going to require a video recording where you just show me what's going on and just take a minute or so. It doesn't have to be very long, but just explain how your program works, prove to me that you did it, right? And just show me it working, all right? So that's that. Any questions about that assignment? Yes?
If you're going to do like a sprite here, something I would also give you a good tip. But if you're going to not choose a sprite than other than cat, I think it's best to avoid copyrighted characters. What do you think?
It's only me who's going to be watching it, so I don't think there's a big issue there. If you're going to post this on the internet somewhere, then that's a problem.
I was just wondering. I just want to know.
Yeah, as long as you don't post it anywhere on the internet. It's just for me to watch as you do it. Other question? Yeah.
When you're choosing sprites, when you hover over it, it shows much different versions of it.
Oh yeah.
Do you know how to get to those?
Let me show that to you. That is, it's over here in looks, I think. It is, it might be layer, it's costume, yeah. Go to change your costume, wherever that is. Switch costume to, yeah. So, yeah, there's other fish. This is one fish sprite that has a bunch of different options. Good question. Where was I? I was in this one. All right. So that's your assignment if you've never programmed before, if you're new to programming. But if you've taken a CSCI class before, of course, I'm going to give you a harder assignment. So please, here is your assignment. Read these chapters of that same textbook and do exercises 6, 7, and 8. And I believe you're also going to make something cool with pictures this time. So that's exciting. And again, talk to me if you want to do something custom. But that is if you don't. So that's your assignment. If you have taken a CSCI class already, you know how to program. Those are the two options. And this will be due on the 31st, last day of August.
Okay then.
All right, if we're happy, that's all that I want to record. And